figure out, all right, at what point do I need to fast forward? Usually when I go live on YouTube, I always tell people, if you can maybe scroll to maybe like the 10 minutes or so, that's when we get all this conversation out the way. So you can actually get right into the lesson for itself. Okay, Aaron, you got a quiz tomorrow for chemistry and then exam for it on Tuesday, both for bio and chem back to back. Okay, now what is your major, Aaron? What is your major? Hey, China Doll RN, thank you so much. Thank you guys also for those follows and those shares of the content. I appreciate that. So we got Cali in the building, Texas in the building, Florida, Wisconsin. All right. Okay, Aaron, you got this. You got it. Alabama. All right, Alabama. Well, I do appreciate you guys for hopping on with me this afternoon. We're going to go ahead and get into our lesson for today. So many of you guys are taking chemistry and you're stressed out, okay? You're stressed out and you don't know which way you're coming or going. Here's why I go live. Because some of you all have professors that aren't always the best at helping you. So that's where I come in. I fill in the gaps where your teachers are making things so difficult. So what I'm going to do is break down this problem in the simplest form. And this is a titration problem. And also, I want to show you all how simple some of these problems can be versus the way your teachers are making it seem. Because I teach, I know what my students need. I know what they want. I know they want the easy route. So I try my best to show them the simplest way they can get this information done. Okay. So let's go ahead and get into that right now. In a problem like this, it says a 15.5 milliliter sample of 0.215 molarity of KOH solution required 21.2 milliliters of aqueous acetic acid solution in a titration experiment. Calculate the molarity of the acetic acid solution. Now, here's the thing that you guys got to keep in mind. Anytime they give you a problem of this nature, and they say it's in a titration experiment, most of the time, you cannot just simply multiply. Like, you can't use this formula right here. Let me go ahead and show you what I'm talking about, okay? You can't just simply use molarity of A times the volume of A equals the molarity of B times the volume of B. It's a little bit more detailed than that because you have to use a balanced equation. And with those balanced equations, you've got to use the coefficients for your acids and bases in order to solve the problem. So it's not just simply using this formula, but you're using this formula in addition to the coefficients of the acids and the bases. Now, in this particular problem, they did not give you the balanced equation. So some of your teachers, if you're taking honors chemistry, or if you're taking AP chemistry, if you're taking a general chemistry class for college, your professors may or may not give you this reaction right here. If they do, count your lucky stars. And also, if they do give you the equation or the reaction, you better hope that it's already balanced. Because if it is not balanced, you've got to go the extra mile to do so. So in this particular problem here, we've got potassium hydroxide, which is the base, okay? So they gave you 15.5 milliliters of 0.215 molarity potassium hydroxide. So because I already know that those two are bases, okay, or information associated with the base, I'm going to fill in my chart. So the volume that they told me was 15.5 milliliters. You've got to convert that to a liter. So that's what I'm doing right now. I'm converting that to a liter. Okay. Now, the next thing they gave me was the molarity, 0.215 molarity, which is also the same thing as 0.215 moles per liter. Remember, molarity means moles per liter. Hey, Kayla. Thank you so much, love. How you doing? I'm glad you're back. Now, you remember when I said you got to do the mole ratio of the base to the acid by using your chemical reaction? Let's first make sure that this reaction is even balanced, okay? In order to do that part. So if I look at my reaction, I've got 1 potassium on the left, 1 on the right. Let's see, for my oxygens, I've got that in check. As a matter of fact, I'm going to rewrite H2O as HOH because that's going to make things a little easier to see, okay? So, and it's the same thing as H2O, but I like to make things simplified, okay? So right here, I've got my H's in check. I got my OH's in check. I got my K's. So this reaction is balanced. And that's what I'm telling you right here. Make sure that you always check to see that your reaction is balanced before solving the problem. Now, going back to the numbers that they've given us, they also told us in the problem that 21.2 milliliters of an aqueous acetic acid solution is also provided, okay? So that 21.2 milliliters is the volume of the acid. Again, convert that to liters, okay? When it comes to molarity calculations, your molarity must include liters. Your volumes, rather, must be in liters. Now, with this problem right here, you're going to be given 4 of the 5 numbers, okay? Again, you're going to be given 4 of the 5 numbers. And because you're going to be given 4 of the 5 numbers, you're going to figure out, well, what is required? And they said to calculate the molarity of the acetic acid solution. So because you've got to calculate the molarity, that is what's required. That is your M. That's the missing piece. Now, here's another little trick to help you remember how to do these problems. Look to see what 2 numbers are associated together. So in this particular problem, we were given the volume and the molarity of the base. So since those 2 go together right here, okay, these 2 go together, you know what we're going to do now? We're going to actually start those 2 numbers together in this first step. So right here, the volume of the base was given and the molarity of the base was given. So what we're going to do is we're going to actually start with the volume, okay? Always start with your volume. 0.0155 liters of potassium hydroxide times. Now my molarity is going to go next, okay? The molarity of the base was 0.215 moles of KOH per liter, okay, of KOH. Now, you know what's going to happen? The liters are going to cancel out. And now in this next step right here, I'm going to put what? My mole to mole base acid coefficients. So that's where I go right up here now. Back to my equation, my formula, my reactant. There, they gave you potassium hydroxide, okay? And they gave you acetic acid. So these 2 right here are what's going to be used for my mole to mole ratio. Well, there's an imaginary 1 in front of KOH and an imaginary 1 in front of acetic acid. So because there's a 1-to-1 ratio, I'm going to put 1 and 1 right there for my mole to mole ratio for the base and the acid. So guess what? That's going to be written right here in this next spot, okay? So I'm going to put 1 mole of acetic acid, okay? And I'm just going to write that out because of the space, okay? And 1 mole of KOH. Now your moles of KOH are going to cancel out. So what's left on top that we're looking for are our moles. That's the first step that you have to do. Remember, the formula for molarity is moles per liter. And they want you to find the molarity of the acid. So let's plug this in, 0.0155 times 0.215, okay? And we get, although this number is in exponents, I'll just go ahead and write that down. 3 scientific notation, 3.33 times 10 to the negative 3rd power moles of acetic acid. You're going to divide that number by what's left over, which is the what? the volume of the acid, okay? We're going to put that number that I'm highlighting in blue on the very bottom. So I'm going to put 0.0212 liters. Remember, moles of acetic acid per liters of acetic acid. Let's divide that and see what we get. Okay, our final answer here is 0.157 molarity. That is the molarity for the acetic acid, okay? That is the molarity for the acetic acid that we were asked to calculate. All right, are you guys following me? So if we go back up here, we just answered that question. Any questions or concerns? Thank you, Rachel. Thank you, Kayla. All right, China Doll. Any other questions? Anybody got questions about this problem before we move on to our next one? So you got to take chemistry in the fall, Kayla? Okay, yeah. Well, if you need a refresher, come holler at me. I got you. If you need a refresher, I got you. All right, guys. So now we got this next problem. Let me go ahead and take a sip of my water. I forgot. You're welcome, honey. You're welcome. Thank you, China Doll. Listen, I try to make these things easy because I know students don't want to know all the jargon. They just want to know what's the quickest way I can solve these problems. Tiffany, you said you came late. You're actually learning molarity now. Well, I got you. Okay, Bernito said 3.33 millimoles. Okay, yes, that is true. But we're not talking about millimoles. Okay. You're welcome, Margarita Jackson. Marguerite, I'm sorry. Alex, you said you're taking chemistry. Today is your first day? Oh, you mean it's your first day learning this topic in general? Okay. All right. Yes, divide the total amount by the volume. That is correct. And when we're talking about the moles, divide the moles by the volume. Yes, the moles by the volume. Yes, I'm gonna go back to that one. Yes, the moles by the volume. So here's the thing, whenever I show these problems, I like to show my students what they need to fill in. So this is my way of being helpful. I give you things that you can check off as you're taking the meat out the problem. Well, for those of you that are vegan or vegetarian, as you take the veggies out of the problem, okay? So you wanna know what you need to solve this problem. If I give you 3 numbers, guess what? You're gonna have to find the 4th one. Okay, but also you're actually looking for 5 things. And let me show you on the next problem. Okay, so here we go. It says by titration, 17.6 milliliters of aqueous H2SO4 neutralized 27.4 milliliters of 0.0165 molarity LiOH solution. What was the molarity of the aqueous acid solution? Now, let me tell y'all something. Notice I did not tell you what was the acid and what was the base. I didn't give y'all that, right? However, here's an easy way to identify what your acid is versus your base, okay? H2SO4, I know that's sulfuric acid. Anytime hydrogen is in front, that is an acid. If you see OH in the back, okay, that is your base, FYI. That is your base. But if you didn't know that, you could actually go wrong with your problems, okay? That's right, Tiffany. H is first. That is correct. H is first. So, Seth, You can use that formula, but you also got to use an extra step in the problem, which is using the coefficients. So yes, it's similar to M1 times V1 equals M2 times V2, which is what we were talking about earlier. Right up here, let me see if I can squeeze it back up. Oh, I erased it. But yes, it is similar to the molarity of the acid times the volume of the acid, which is equal to the molarity times the base times the volume of the base. But when you're dealing with titration problems, you've got to make sure to use the coefficients to use the extra step. Okay, that's the only extra problem or extra step rather to doing titration problems. Yes, Kayla, that's an easy way to identify that. Yes, yes, yes. That is a very simple way to figure it out. Yes. Now, you want to make sure, like we said before, guys, that we check to make sure the equation is balanced in the step. So we've also given the pieces that we need. So let's fill that in first before we balance the equation. So the volume of the base that they gave us was 17.6 milliliters, but I'm going to convert that to a liter, okay? They also gave us the molarity of the base, or did they? Wait. Look, let me go back. I'm sitting there trying to write and at the same time. Let me redo that. Sorry, guys. They gave you the volume of the base. Sorry, that's the 27.4 milliliters. My bad. 27.4 milliliters. Yes, La Colombiana. Yes. Put that question on my last video and I can go back and explain that more, or just bring that back. As far as studying for the CLEP exam, I would recommend that you binge watch a lot of my videos. I don't have study guides per se, like on hand, on deck, but what I can tell you is that the CLEP exam requires you to get like an AP chemistry book or chemistry for dummies. So that way you're able to recall a lot of information, but you can binge watch a lot of the videos. Okay, Philip, if you can't use a calculator, good question. I would always recommend that you round the numbers off to using whole numbers. So in other words, I would make 17.6 20 milliliters. I would make 27.4 milliliters 30 milliliters. Like I would round off to the whole numbers that allow you to work with easier numbers. Kat says, how do you know which is the base solution, which is the acidic solution? You're welcome, La Combina. Because the LiOH, the OH tells me that that's the base. So they gave us 27.4 milliliters of lithium hydroxide. So the molarity of that was 0.0165 molarity. Okay, let me convert that milliliters that they gave us to liters. So that is your LiOH, the base. Now, let's make sure that our equation is balanced also. We've got, and remember, I'm going to rewrite H2O as HOH because it just makes life easier when you're trying to balance your equations like right on the spot, okay? So I'm going to take a look and see if everything is properly balanced. We've got 2 hydrogens on the left. Well, actually, we got a total of 3, okay? 3 hydrogens on the left, but we've got 2 on the right. We've got 1 unit of SO4, Li. So we need to go ahead and balance the lithium. So I put a 2 right there in front of LiOH. And guess what? I've got to also balance out my oxygen, and I put a 2 right there. So now my equation is balanced. But here's the thing. If you do not balance the equations, your answers will be wrong in the interim. So because I'm dealing with this acid right here and this base right there, the ones that I'm highlighting in yellow, those are going to be my coefficients for this next step right here, okay? Where it says mole ratio of the acid and the base. So guess what I have? I've got 2 moles of the base and I've got 1 mole of the acid. And speaking of the acid, let's write down the volume that they gave me, which was this number right here, 17.6 milliliters. that we're going to convert to a liter. Okay? Now, what is required? The molarity of the acid. That's what they were asking you to find. The molarity of the acid. Okay? Now, in this next step, remember what I told you before. Identify which two set of numbers go together. When you see the word of, that tells you that those two are going to be multiplied together. So the 27.4 milliliters of 0.0165 molarity, those two go together. So we're going to actually start with those two numbers, but we're going to start with the volume. So I'm going to convert that volume right there, 0.0274 liters, okay, of the lithium hydroxide. I'm going to multiply that times the molarity of lithium hydroxide, okay? And remember, 0.0165 is also equal to 0.0165 moles per liter. And I keep writing those units down because so many students forget that molarity is equal to moles per liter, okay? Now, in this next step right here, I'm going to take these coefficients, the 2 moles of the base and the 1 mole of the acid, and I'm going to put that right here, okay? I'm going to put that right there. Remember, on the very bottom, I want to get rid of my base. So I'm going to put the 2 right there, okay? The 2 moles of lithium hydroxide, which again, that comes from our coefficients right here, and the 1 mole, okay, of my acid. And remember, the acid that they gave us was H2SO4, okay? That was my moles of my acid. Now let's go ahead and cross out things that we don't need. We don't need the liters, okay? We don't, and I wrote moles right there, trying to write fast. Sorry, y'all. We don't need the liters of the lithium hydroxide. We don't need the moles of lithium hydroxide. What's left over right here are my moles of H2SO4. But what we're going to do now is calculate that across. 0.0274 times 0.0165 equals. And then divide that by 2. And we get 2.26, because we only need 3 of those numbers, okay? Times 10 to the negative 4 moles of H2SO4. Now, don't forget, guys, don't forget that molarity is equal to moles per liters, okay? And remember, the liters that we got to use are the liters from the acid. So we're going to put that number right there that I'm highlighting in pink. We're going to put that on the bottom. Whoops. Okay, we're going to put that number on the bottom. And that's at 0.0176 liters of H2SO4. And again, that was what was given in the bottom. No, Aaron, we don't divide by the total because, and here's why. This problem did not say that we added additional acid. It says by titration, 17.6 milliliters of aqueous solution neutralize this amount. Now, if I would have said I added more sulfuric acid, then that's a different story. And I think I did a problem like that earlier this week. Okay. Yeah, so and I'll go back and hit you up on that one, Eric. So after I finish this one, I'll go back and answer your question. Yes. Okay, you're welcome. So we're going to take that number and divide that by 0.0176, and we end up with 0.0128 molarity of H2SO4. Okay. Thank you, Max. Thank you, Alexis. How you doing, Alexis? I haven't seen you in a minute. I love the fact that you guys are able to answer those questions. Thank you, thank you, thank you. Teamwork makes the dream work. Oh, yes, Alexis, I get it. I get it. All right, guys. Now, I've got one more problem that we'll do before I answer some of y'all's questions, but also, too, notice how in these first two problems, we were trying to find the molarity of the acid solution, right? Well, what happens if you're trying to look for the molarity of the base? Do you work the problem the same way? Yes, you do. Yes, you do. But also, let me say this too about that. When you read these problems, okay, when you read these problems, you need to identify what you are given and what's required, okay? Fill in the missing pieces. And if you know an acid from a base, then these problems should not be difficult at all. But let me go back and answer and address. Oh, you're welcome, Ladia. I'm sorry if I'm mispronouncing your name. Titration experiments requires patience. And I've shared the story with you guys before that if you're doing a titration problem, particularly with phenolphthalein, that pink color brings back nightmares in undergrad because we were wanting to rush through the titration experiment. We had to literally count the drops. Our professors made us count the drops. And I mean, literally count the drops. And if we over titrated, that means the solution became like this dark pink color using sodium hydroxide. And as a result, we had to start all the way over. Otherwise, we were going to get a 0 for the lab because our data would have been wrong. So that's why titration requires patience. Yes, Alexis, that first titration is the worst. And yes, Bernito, it should be a faint pink. When you see that it's getting to that darker pink, that's when you need to just stop. That's when you get to what we call the end point, the end point. Now, to go, let me say something also about these problems, okay? So you see how I was saying you got to make sure that your equations are balanced. And here's the thing, if you did not use your coefficients, like let's say this problem that we did yesterday, if we did not use the coefficients and we just stopped here at what I wrote in red, okay? Your answer would be half of that answer, well, this answer right here. The final answer would have been like 0.625 because you did not use the 2 as that last step. So although someone had asked, isn't this just a M1 times V1 equals M2 times V2 problem? Yes, it is, but you also need that extra step of multiplying your mole to mole ratio in using your balanced equations. So if you forgot to use the moles here, the coefficients, and you didn't do that last step, you would get the problem wrong. And guess what? On these tests, they will put those answers there for you not using the last step that I'm showing you right here. Okay. So if you don't use this step that I'm highlighting in pink, if you forgot to do that last step, then your final answer will be wrong. Okay. Just FYI. Also, you do get lucky if you forgot to use coefficients. You do get lucky when you have a 1-to-1 ratio, like in this problem, 1-to-1. Hey, Chavez, how you doing? You do get lucky if you have a 1-to-1 ratio because those ones aren't going to matter in the final answer. But the likelihood of that happening is slim. Most professors want to challenge you to make sure that you've taken all the proper steps and procedures. I know, right, Benito? That's why I go live, and I also started doing this on YouTube because so many students, TikTok would hold my videos and I could not upload them to let everyone see them or even edit them. So that's why I go live on my YouTube channel at the same time so that they can get that. But I appreciate your kind words. All right, Loco, did you do good on your test? See, okay, you see what Alexis just said, right? Alexis is also a chemistry professor. And Alexis said that she puts a 2-to-1 problem on her titration test. Lexi, you got this. You're going to do well on your test. You got it. And come back and let us know tomorrow how you do. All right. So see, professors do put these types of problems where it's a 2-to-1 ratio instead of an easy 1-to-1. So I'm just saying. I'm just saying. And now, let me see. What was the other question? Aaron, you had asked me a question about something else. Remind me, Aaron, of what you asked me. See, I'll be on a tangent. Yes, I learned to use dilution equation based on equivalence. Yep. Okay, Steph. Excellent. Excellent. That's right, Alexis, all the time. Okay, thank you, Aaron. Thank you. Now, I'm going to do the one last problem that deals with the basis, okay? And again, yes, Yan Yan, I do have a YouTube channel, Learn Chemistry with Professor TK the Chemist. Learn Chemistry with Professor TK the Chemist. All right. So now, here is the last question that we'll do, but this one deals with a base. Again, notice. That's right, Alexis. I'll be trying to give examples like that too. That way they're able to digest stoichiometry because everybody seems to think that stoichiometry is a lot of extra steps. But when we break it down in the simplest forms, they realize we do stoichiometry every day when we're planning parties. If I got 100 chicken wings and I'm inviting 20 people, how many chicken wings will each person get? 5. Nobody can be greedy. That's stoichiometry, okay? In a fun way. Now, this problem says if 20.0 milliliters of 0.0100 molarity aqueous HCl is required to neutralize 30.0 milliliters of an aqueous solution of sodium hydroxide, determine the molarity of the aqueous base solution. Okay, that's right, Alexis. Y'all take note of what Alexis is putting down in the chat. All right. So what do they give us in this problem? Let's identify it. We've got these two right here, 20.0 milliliters of 0.01 molarity aqueous HCl. Listen, y'all, hydrochloric acid is also found in the stomach. If you didn't know nothing else, HCl, you should be, if you're taking biology, you would know that also. That's the acid that's found in our stomachs. But here's the thing, though. Here is the thing. Because those two go together, we know that that's going to be two numbers that we're multiplying. And although we will be dividing by what's left over, okay, this 30.0 milliliters of sodium hydroxide, we also know that we have to go the extra mile in our final step. And that's based on this step right here in terms of making sure that our chemical reaction is properly balanced, which in this case it is. This is a 1-to-1 ratio. So we're good right there. Okay, this is a 1-to-1. The volume of the acid that was given in this problem was 20.0 milliliters that we're going to convert to what? Liters. Okay, of HCl. Molarity that they gave us was 0.0100 molarity. Again, that's the same thing as 0.0100 moles per liter. The volume of the base that they gave us was 30.0 milliliters. Again, you're going to put that at 0.0300 liters. What is required? The molarity of the base. Yes, I do. I do have some videos, Yang Yan, on ice tables. Yes, I do. All right, so let's go ahead and solve this problem, guys. What we do know is everything here, okay, that you can see. All right. So what am I going to do? I'm going to start off first with the liters of the acid. 0.0200 liters of HCl times. And in this step right here, I'm going to go to the molarity of the acid. 1 liter of HCl was equal to that 0.0100 moles of HCl. We're going to cancel out our liters. We don't need those anymore. Okay? And then right here in this step, we're going to go to our mole to mole ratio of the acids and bases. So we're going to put 1 mole of sodium hydroxide on the top and cancel that with the 1 mole of sodium of HCl. Okay? I've been trying to write faster than I can get it out. So our moles of HCl cancels out. And now you're left with finding your answer for your moles of sodium hydroxide. But let's see what we get right here. 0.0200 times 0.0100 equals 2.00 times 10 to the negative 4th power moles of sodium hydroxide. Divided by. Now remember, we forgot the last thing, okay? Hey, protein tracker. Then what are you going to do? You're going to divide by that last number that we did not use, okay? We did not use the 0.0300 liters of that base. So we're going to put that on the very bottom, 0.0300 liters. Okay? And so we're going to divide that number by 0.0300 and we get, and y'all, I know some people say, oh, that's a devil number. It's not. It's not. 6.6666 times 10 to the negative 3rd. Well, if it makes you feel better, you only need 3 of those numbers. So you're going to say 6.67 times 10 to the negative 3rd molarity. Okay? Or you can say 0.000667. I know some people get creeped out about numbers. Okay, so this is your answer right here, okay? And let me make sure that we put sodium molarity for sodium hydroxide, okay? I'm gonna let that breathe for a second. Okay, let's see, Aaron. DM me and I can let you know, okay, for April the 15th. Let me see what, I don't have my calendar in front of me, but I'll get with you. Yeah, DM me and I will get back with you today. So as soon as we get off this live, I'm going to DM you to let you know my availability, okay? All right. One thing I need to show you too is an equivalence chart, and I forgot to insert that. So let me go ahead and see if I can insert the equivalence chart. I think I downloaded it. Let me make sure. Yeah, there we go. So I wanted to show this to you too, okay? So right here, it tells you, it says whenever you have, let me just say approve so that can come off. Okay, there we go. Whenever you have a chart of this nature, when you talk about the equivalence point, if you are doing a titration lab where you have a strong acid titrated with a strong base, here is your equivalence point right there in the middle. So you start off high with a strong acid, and then you titrate it with a strong base. Here you end up with your chart, your graph, okay? See how it starts here? Remember, strong acids, the further they are away from the number 7, the smaller the number. And as you titrate it, okay, you see how the curve goes all the way up versus a weak acid titrated with a strong base. Goes up a little further, okay? And as you can see, it pans out right there. If you utilize Yes, thank you, Alexis. If you utilize these graphs and these charts when you do your lab experiments, your teachers will put things like this on your test. And what they may do, they may, cross this out right here and tell you to fill in the blank. So I'm crossing this out and seeing if you can identify what type of acid-base solutions do you have? So if I blank those out and I tell you to fill in the blank, what type of acid is being titrated with what type of base? Strong or weak? So when you have things of this nature, your teachers will want to make sure that you're able to interpret graphs. Graphs are the way of the world when it comes to your math and science classes, analyzing data. Okay, Aaron, what do you mean? What's a basic concept question problem for titration? Okay, yes, Philip, you're correct too. You would say that question another way, Aaron. I don't know if I'm following you on your question. Okay, so yes, so while I'm waiting for Aaron, someone had asked me also earlier a question about enthalpy. Are you still on? The person that wanted to know about enthalpy. But yes, so when you talk about titration problems and molarity, just know if it's a basic molarity problem, the words titration won't be involved, just as a little way to identify what you're trying to solve. Whoops. Mm. Okay, so let's see here. And again, it's usually, again, with some acid base. Okay, which acid is more acidic? Okay, gotcha. So I always tell students, well, okay, so like okay, gotcha. If you are doing problems of this nature here, and you're trying to figure out which one is more acidic, look at the calculated pH also, okay? So like for instance, if I tell you, and this may not be your question, but like if you did this problem right here, okay, let me go back up to this one, and I tell you to calculate the pH of this problem right here, 0.0128, to see how strong this was, okay, or how weak it was. You could just take the log of it, the negative log of that value, to get the answer. But if you're looking at different names and you're having to figure out which one is stronger or weaker, um, there are oftentimes charts that I give students to help them remember these processes here, okay? In terms of their strength. And I did a couple of experiments here, but let me show you another example. And it's also based on the oxygens that are involved, okay? Because when you talk about the strengths, it depends on the type of oxygens that are involved. It also depends on the central element as well, okay? So if you're asked to choose between a strong conjugate acid or a weak acid, or a strong conjugate base or a weak base, I would tend to have you guys analyze a chart, okay? To determine that. So for instance, you have HCl and HClO4. Those are classified as stronger acids, okay? Whereas if you have, let's say, a strong base, if you typically have things like ClO4 or H3O plus, like those are considered to be weak bases. So it just varies depending on what you're being asked to solve. And also a chart like this, okay? Now, those of you all that are on YouTube, you're not going to be able to see this, but this is just in one of my chemistry books right here. Okay? If you guys can see that. And also, I tell students all the time, as much as y'all don't want to do extra work, I still say make you some note cards with these assets and bases on them. Thank you, Alexis. Yes, screenshot what Alexis just stated. Okay, I would highly recommend that you guys make note cards of things that are in your book, because sometimes you have to write them down so that it can become a part of your memory bank. Even though we learn differently, we all learn, our study habits are different. Some of us are auditorial listeners, so we can just hear something 2 or 3 times. Some of us are visual, where we got to see it. And then others of us are kinesthetic, where we got to do it. We got to write it down and then apply it to an actual problem. Sometimes it takes writing these problems over and over and over and redoing them, even if you got the problem right, just so you know that you're on the right track. Okay, so yes, I would highly recommend that you guys get your stuff. Now, I don't want you to overstudy, no, but study in small bite sizes. Study in small bite sizes. That way, you're able to retain the information more than if you're trying to study all day long. In that case, less is more. Here's another chart. Again, I'm sorry, YouTube, y'all can't see this, but I may insert the picture on the video. But these are some common aqueous solutions that are strong and weak. And then over here, these are your bases. So what I may do is put them up online. But again, for those of you out that are taking chemistry, you would have these in your book, or on your in your lab book. Print these charts off. I know a lot of our chemistry books are ebooks. But I'm still old school, as you can see. I love a hardback book more so than a electronic book. But even if you get PowerPoint slides, print those slides off so that you can refer to them in your notes. Again, y'all, screenshot what Alexis just stated. Alexis is dropping some tea in the chat. Yes. So, you all just keep doing what you're doing in terms of your studying, but don't stress yourself. But please make sure you do go and reach out to your professors or to your teachers. For those of you guys that are taking AP chemistry, make sure you reach out to your teachers and tell them, look, I don't understand, but make sure that you go to them and show them where you at least initiated the start of a problem. Okay. So if you're initiating a problem, make sure that you can show at least somewhat where you started to do the problem and where you got lost. If you just go to them and say, I don't know what to do, then your teachers are going to have a hard time trying to help you. It's no different than if you go to the doctor. You just can't say, I'm sick. Well, what part of you is sick? Your head, your neck, your back, your stomach? Yes, like Alessia said, yes, please ask questions. Understand, we know you are learning, and it is understandable to have questions. That's right. And let me tell you, like I said yesterday, we actually give students pointers during office hours that we would not necessarily give to the whole class because we have a limited amount of time. So an hour 30 class or 50-minute class, we may not remember to tell you everything that you need to know. Okay, TikTok tell me they're going to kick me off in about a minute, okay? So, yes, office hours are where we can focus on you. That is right. That is correct. That is correct. So, yes, guys, if you all need extra help, you all know where to find us. Alexis is also a chemistry professor, so you can get some help from Alexis as well. Now I don't know, Alexis, if you're doing it, but I'm just putting it out there if you are. Make sure that you guys look for tutors at your school also, because they more than likely have had the teacher that you're going to them for help for, and they can give you tips and tricks. Excellent, Alexis, excellent. They give you tips and tricks on what to master for that particular professor's class. Sometimes the tutor center has students that have had Professor so-and-so. And this is what I would do if I were you, because this is what they did during our class. So you just never know. You never, ever know. Okay, guys. So I hope everything works out for you all. And we will pick this back up tomorrow as well. We'll do some other stuff tomorrow also, for some other chemistry units that I have on the same chapter. But Aaron, don't forget to DM me so I can tell you my schedule, okay? A loco said, I'm friends with the chem tutor. That's the best way to be. That is the best way to be.